Another way to develop the standard division algorithm is to use repeated subtraction. So if I'm looking at the number 726, I can subtract 6 repeatedly until there's no more 6's left to subtract. Now if I started with just subtracting 6 like this, that would take forever. In fact, we know that the answer to this division problem is 121, so I would have to subtract 6 121 times. Instead, let's be a little smarter about it. For example, if you had $726, you probably would have 7 $100 bills. And if that were the case, you could subtract 6 of those $100 bills in one go. That would be like subtracting 6 100 times straight away. That would only leave 126 left to deal with. Next, I'm going to subtract 6 again, but I want to be strategic here. If you happen to know that 6 times 20 is 120, you might jump straight to that. But if you don't remember that fact, maybe you subtract 6, a nice even number, 10 times. That would be like subtracting 60. 12 minus 6 is 6. Carry down my next 6. I have 66. Looks like I can subtract another group of 10 6's. That leaves 6 behind. I can subtract 6 one time. And I'm done. As soon as I hit 0, I know that I have finished the division. There's nothing left to work with. Now I go back and I look at all of the times I've subtracted 6. 100, 10, 10, and 1. I would add these together to get 121. I was able to remove 6 from 726, a total of 121 times. Now we can use this to develop the standard division algorithm. Instead of looking at 6 going into 7, we can look at it as we've subtracted 6 100 times to get 100 6's. We subtract 6 another 10 times, or we did it twice, so we could subtract 6 20 times. And then finally we can subtract 6 just once. And then the answer to this problem would be the sum of 120 plus 6. Very similar to what we do with the division algorithm, except for I'm using a stacking method on top of my division bar to show each step where I've removed groups of 6's. In the standard division algorithm, these zeros just collapse and the numbers fall into place. But the bottom looks exactly the same.